So one thing, I looked over some of the homework problems. I never actually in the notes at all talked about what this, how this vorticity comes into play, or irrotational flow. So I'm trying to fix that right now. I may upload some notes later, but all the irrotational thing is another differential operator on a velocity field for fluid. So that's this cross product of all of your elements in your vector. So it's defined like it's defined like this. I hope you might not be able to see it, but this is dw, dy, dv, dz, and it's the difference of the two things. So irrotational flow is a saying we give if given my velocity field of the fluid, if I take the cross product, this would be zero, and that would be component-wise. So this is a zero vector. So irrotational flow is when this is 0, 0, and 0. So irrotational flows are flows that are nice because what happens is before, when we had this body of fluid that was a vector field, right? You can draw these little elements, these little bits of fluid, right? And before, almost everything we talked about was just tracking this, right? Was tracking the center of mass of my little bits of fluid. That was this little vector that I had. But what the cross product will tell you is how much does this actual little bit of fluid rotate around as it's moving with this point. So it's helpful because irrotational flows, if this is satisfied, and your book goes over this in a little chapter, it talks about how if this is satisfied, then I can actually claim that I actually have some potential function for the velocity field. So just like that string function, all the components came from, right, differentiation. If this is true, you then can compute all the velocities just from a special function. And that's where your book will go into Bernoulli's equations can be derived based on this inviscid irrotational assumptions. But your homework will involve actually doing these calculations, which are just which are just taking partial derivatives. So understanding how to take a derivative. And if you're given a velocity field, take some derivatives and verify things. So calculation-wise, you should be able to do that where you're just going to take these derivatives and see if something's equal to 0 or not equal to 0. But that's left as an exercise for the homework. So I hope that maybe just writing these things out allows you to do the homework a little easier. I also recommend that everyone in this class right now should be looking over the book for equations to help them solve homework, because it's just a good habit, right, to read the textbook. Okay.